Topic is on digital forensics called These Artifacts Aren't Fiction. My name is Matt Schuerer. My co-presenter today is Tuan Phan, and he will introduce himself here momentarily. Quick introduction about me. Work for a big, well-known organization. They don't let me talk about it. However, I do digital forensics and incident response. Done it for a long time. They call me AVP, whatever that means. I'm also a podcast host for ThreatReel. We've been in the dustbin for a long time, hopefully getting started up this winter again. If you're not connected with me on social media, do hit me up on Twitter or the X social media platform. I'm an official Hacking is Not a Crime advocate. Hacking is not a crime. Cybercrime is crime. If you want to know the difference, check out their website, hackingisnotacrime.org. I'm also a technical mentor for WAMSA, which is the Women's Security Alliance. Always looking for mentors and mentees. Please do get involved in that if that's speaking to you. WAMSA.org for them. And I'm going to let my co-speaker introduce himself before I take back over here.
Good morning. My name is Tuan Phan. I'm with the Independent Info Security Researcher. This is my first time here at the Securewv West Virginia with Matt here, so thank you for having us. I also cannot tell you exactly where I work either, but I can tell you that, yes, I do have a day job. I work at the well-known big financial institute here in the U.S. I serve them as an AVP for eDiscovery and DFIR. Before that, I was pen testers and also malware analysis and stuff. My focus is more of eDiscovery and forensics investigations. With that, yes, so both of us do have our day jobs. However, both of our opinion is expressed based on our independent security research. It does not reflect our view of our employers, so do not blame on them. If anything, just let us know. With that, we are not lawyers. This presentation is for educational purpose only. Please consult with your qualified legal counsel before taking of any of our techniques or these techniques in any of the actual investigations. We flatter that you do, but do not blame on us, but let us know so we can laugh at it. Due to the time constraint of the presentations, Matt and I both have a lot of things to go over. This topics up here are out of scopes. Third-party forensically sound memory capture, such as the memory dump during the live triage or the incident response process. There's imaging tools such as NKs, FTK, autopsy, SIF, any of those type of tools that can do this imaging cloning bit by bit. How to do the change of custody, intake of the evidence, tracking them and stuff like that. Court case and trials, those are very different topics. How to do the data handling, acceptable practice. Those are more of forensics fundamentals, forensic methodologies. In terms of also isolations of remote access when or shutting down or disconnect the workstation during the live triage or the incident response. Most of this will be out of the topic area, but please let us know if this is interesting you. We'd be happy to talk about it. Next slide, something like that. With that, I'll turn back the mic to Matt here, the rock star.
Thank you, Tuan. So quick commentary on data preservation methodology. The idea behind this really is you want to make sure, first and foremost, you have a forensic image. Even though we don't talk about how to do the memory dump, get that first. Did a forensic image of the system hard drive. And while you're making a copy of that image, that takes time. That's a great time to actually do some of the live triage that we talk about here and the live eDiscovery acquisition. So while that copy is happening, that's a great time to do this stuff just because it takes time. The forensic copy is really just a copy of your forensic image, and that's really what you want to work from. And again, while we're doing eDiscovery, we want to really still try to minimize activities that could modify system data, access times, those sort of things as much as possible. So I'm going to start off talking first about the Windows SRUM database. The System Resource Utilization Monitor, or SRUM, is built into Windows 8 or higher. System app history is how it's listed in the operating system itself. And that data is recorded in an ESE database format, which is a database format that Microsoft created. They've more or less open sourced it, and so there's some tools we're going to talk about a little bit later on how you can actually view that data. The database file name itself is srudb.dat, and we'll talk about that file. That's actually located under the C Windows System 32 srudb.dat file. Think of the SRUM database really as holding the same levels of details typically found in most commercial EDR platforms. Now, it doesn't give you the monitoring, detection, alerting, response capabilities an EDR would. What I will say is I'm not saying use the Windows SRUM database instead of using a great tool like Sysmon or your SIM platform, but you can use it, one, to collaborate the data to basically provide further proof or evidence, but also you may not have those things running in the environment. You may not have your data ingesting into the SIM, or you may not have Sysmon running or configured in an optimal fashion. So this is a great go-to when you don't have those other things available. Useful SRUM data. Understand, Microsoft never really intended for you to use this for forensic purposes, but it's got such great details we can sort of do that. Really, it has a lot more information about the running system itself than we would actually care about from most forensic standpoints. So we're going to focus on really two key areas. One is the application resource usage, and the other is network usage, and we're going to drill into some specifics here. So there are some great tools for doing this. SRUM dump 2 can sometimes be a challenge getting the programming language working right on the OS, but it's a great free tool you can use to dump out data. Velociraptor is an open source project. It's now maintained or managed, if you will, supported, backed by Rapid7. They do great work with that. It's a great tool. Also, Nearsoft has that application resource usage view and network usage view are utilities that you can get. These slides are available if you go to slides.dfirmat.com. You can download a PDF version. All the hyperlinks are there and so forth. So if you want to just make note of that site, slides.dfirmat.com, you can get the slide deck today and have links to all these resources I'm discussing. Here's just a quick example, and it's probably going to be a bit of an eye chart with the screens here. But what you get when you're looking at the example output from the SRUM database, you have timestamps, you have the actual path where the executable is it's running, you have the user SID it's essentially tied back to. Now understand, if something's running on user context, it may not be something they specifically executed. It could be, but it's something that's running under their user context as opposed to running as system, those sort of things. So this is really valuable information. We'll look at some more specific examples here. This, by the way, is a worst case example. So this is if nothing else, if you just copy the srudb.dat file and you look at it offline, you can actually get a lot more detail if you're doing this on a live system, or if you export the registry out and import those keys into the utility. So this is a worst case scenario, and it's still fantastic information because it's still giving us timestamps, the application name that ran, it's giving us the cycle times, which gives us an idea of how long something may have been running. It gives us the bytes read and written, and also the number of read and write operations. So that can tell you an awful lot about what a particular file or process actually did on a host while it was running. And so a lot of great application information. You can combine that with the network resource usage, which tells you really how much network activity happened. So that's going to give you, at the very least, again, this is worst case scenario here, you're going to get a timestamp, the application name in this case, in the screenshot, maybe a little hard to read. This is Microsoft Edge web browser as an example. It's giving us the user SID it operated under. And again, if you have the registry or on a live system, it'll actually tell you the username, but you can still marry that up with the the user's SID for a system and determine what user context something ran under. And then also to give you an idea of the bytes sent and received. If you're suspicious of data exfiltration, for example, this can be one of those things that gives you that telltale sign. And again, when you combine these with the application usage, you can start to paint a picture and tell a story forensically what happened on a system. And again, this is just taking advantage of what's already built into Windows. So this is really valuable insights when we're doing an investigation and we're trying to understand who, what, where, why, when, and how. So some quick SRUM database conclusions before I turn it over to Tuan to talk about browser artifacts. The Windows SRUM database helps us with identifying file execution, answering the question, did it run? What user did it run under? So that helps us with user attribution, activity correlation, and then also timelining of system events and understanding what happened when on a host. And now that we've tamed this through, I'm going to hand it back over to Tuan.
All right, thank you, Matt. Web browser artifacts. What we want to do is talk about them, what they are, where they are, how they're important to us in terms of the investigations, and what tool do we use to parse them out for any type of investigations or incidents. First, what are they? They're basically the breadcrumb or the artifacts that left behind by your favorite web browser. Could be Safari, could be Edge, Netscape, if you remember those. Chrome, Edge, and stuff like that. It left, by them on your computer. Every time you visit a website or a URL, your computer or mobile will then keep those data for later usage, such as, optimizing, leveraging them for efficiencies and stuff like that. Could be logs, could be debugging and stuff like that. Most of the artifacts not really intended for forensics purposes, but more like system usage and stuff. But we as a forensic practitioner use this artifacts for investigation purpose. Different browsers then store these artifacts in different locations, primarily under the user profile of the Windows, but they're primarily different folder structure because of the naming conventions. And we'll get to that. So why are they really important to us? Well, what do they do for us? They basically are central to the digital forensic examiner and incident response team. The artifacts or the breadcrumbs basically help identify, paint a picture of who did what, where, and when during the malicious traffic attacks. So you know exactly where it come from, who did it, how they did download it, and stuff like that. It's also great for HR, proxy policy violations in terms of, hey, Matt here, what did he do during the day? What did he search for? Did he went on gambling.com or did he bid online? Something like that. Right, it's great for that report. So what tool do we use to extract the data and to do the analysis? There's a lot of free and open source out there that you can leverage. Browser History Examiner, which is the Foxtron, the Browser History View, and the Browser Download View from Neurosoft. If you took SANS class, you probably know this type of tools, and it's free. There's also DB browser for SQLite. Most of the browsers nowadays use this particular SQLite database. It's easy, it's quick, and it's available for them. So this tool will allow you to parse the data out and get your information. There's also Hindsight. Not too many people use it, but it's primarily for Chrome analysis. There's also a third-party commercial forensic tool as well. So if you're in the enterprise, you do have something for enterprise checkbox. So don't worry about that. So with that, what it does and how important it is, what tools to parse it. So where the artifacts coming from, it could be from the suspected hard drive or suspected laptop, desktop, mobile phones, such and such. Forensic clones, hard drive image, like he's mentioned earlier, memory dump during the live triage for incident response, or the database file that, during the live triage, the incident response or forensic team will extract it for you, or the other files such as the user profile. To me, that's the most important things, to have it and to extract it out and then to point to the data to it. What we want to talk about is the high value artifacts. This is now we're going down into the web browser artifacts itself. Most notably, the history URL. This is my favorite. I actually tell you the whole thing, the picture itself, into terms of who did what, where, and when. It's the type of URL, the searches that they did. Cache is where, most of the picture slides, thumbnails, or the JavaScripts and stuff, if they run any of those executions. Logins, this is my not really favorite one because it actually keep all your logins and stuff. Like your credentials, yes, it does provide the password and plain text. So try it, but don't let me know. Cookies is great for investigations. From values, this is great too. If you go shopping, it's also auto-populate all the stuff for you, your address and stuff. It won't do your credit card, so it's not there. Downloads, what you download, what file you download in terms of executions. Favorites, aka bookmarks, if you remember those. So the next thing we want to touch base is the private browsing. Yes, so it's, aka known as incognito. If this browsing modes allow a user to surf the web without retaining any of those breadcrumbs on the workstations. Now, if you're in a corporate, it still rely on the proxy servers and stuff. So if you need that information, it's in there. Otherwise, it's hard to get those data because they don't keep those on the workstation itself. So the only way to get it is by memory dump during the live triage. Incident response or pen testing do that. They dump the memory for the memory analysis. So every time the memory is being dumped, it's not only contain the processing, it's also contain other stuff, such as the web browser artifacts. Now, it's important that you know exactly the timeline, so you go in and look for your artifacts. Otherwise, it would be like looking in a needle in a haystack stuff. With that, here's an example of the history URL, the high value. Like I said, mentioned earlier, this is the best one because it provides you exactly what the user visited. Here's an example of the tool out there, the Browser History Examiner. You can see the date the user visited, the title of it, and then the URL of the title, and then what type of visit did he visit. Is it the link? Is it the redirect? Or is it something that he typed in? How many count did it went back? So this is maybe misinterpreted because the type can be refreshed. Some pages are dynamic. Here's an example of the history artifacts path. This is important because usually when you use a tool like the Neurosoft or any other tools, it's required you to drill down to where the artifacts live under your system profile. So the Edge and Chrome is almost exactly identical, just the naming conventions. Mozilla Firefox, as you can see there, is under your username, app data, roaming, Mozilla, Firefox, and profiles. So you need this type of path to point the data to point the tool to it, so it parses out the data for you. We'll get more to that. Here's an example of that history being parsed out. This is another tool. As you can see, you can load it in using the timeline, basically when you wanted to extract the data out, what type of web browser it was used. If you don't know it, just click all of the above. Once you know what you're doing, you click on next, and it go to the endpoint or the workstations, and it will bring back to your data. So the data, again, it paint you the picture, the URL, the title of the URL, what time the user actually went there, how many time that page has been refreshed, what type of browser it's using, and the profile that it was used. So this is great for the investigations if you want to know who did what, where, and when. Once you get the data, you can also parse it out to the CSV file or Excel file. That way you can slice and dice, make it look nice for your HR or your manager, and let them know that, hey, Matt here violated such and such. You can also use a SQLite database browser too as well. As I mentioned, one of the tools, you can parse it out. Incident response team and pen tester love this tool because it's just quick and it's just efficient for them. It gives you the same thing. If you know how to use database and SQLs and stuff, you basically select the table of the URL and it drop down telling you the same thing, the URL, the title, the visit count, just like the other tool does. The only thing difference is the SQLite doesn't really give you the exact time. It's give you the system time, which is like you have to know if you use Safari, it's Apple time. If you use Chrome, it's epoch time. So you have to convert them back to the real time that the system is. That's the only thing I hate about it. Next, I want to address is the type address URL, which is one of the other high-value artifacts. This is important because when HR asks, hey, did Matt really went to facebook.com? This can be misinterpreted too as well because, nowadays the system is smart enough. If you type in FA, it's already know it's Facebook, and he can select it. But you can tell that, yeah, he type in FA, that's Facebook, he selected, and then that's the URL is next. So it depends on your investigation, how you interpret it, and how you provide it to the HR or your manager. You can also find this artifacts in the registry too as well. So the window registry usually normally, keep everything there too as well, but they usually overwrite themselves. So as you can see, it's under the software, Microsoft, Internet Explorer, and typed URL. Here's an example of the typed URL that being parsed out by the browser history view. It tells you exactly the same thing. Most of this are very consistent. The URL, the title of the URL, the visit time, visit count, and then you see their visit type. What type is it? Is it the typed URL, or is it redirect, or is it a link that he clicked on? And it tells you the visit duration too as well. So this is great when HR said, how long was he there? And also the artifact is also in the registry too as well. It's not intuitive as a tool, but it is there for you to use it, to leverage. Next is the browser cache. This is one of my best actually too, is it contain all the various websites such as the image Java files and JavaScript files in case if you want to do any malware cases that, investigating on. What picture did, Matt search for, and what file did he click on? What, JavaScript it was run on that workstations. Example of the artifacts path again, Edge and Chrome, store differently. They're in the same location, just different naming conventions. Firefox, as you can see there. And again, this slide will be available on Matt website, so you can download that and use that for reference. Here's an example of how the cache being parsed out. So let's say if you use any type of image investigations, did Matt, love cars? What did he search for? It looked like he searched for Formula One there, and he loved cars, so there it is. Case closed. And if you have something like a JavaScript or something that, hey, did he click on it or not? It should be in an other bucket. So downloads is also a great place to visit. This is where the user files are downloaded or saved. It can be configured. Sometimes, user would configure it to their thumb drive or to their share drive, but majority, they usually default in the download folder under user profile. There's an example of the path where the download folders are being stored. You can use a tool and basically point to this artifacts path, and it parses out the data for you. Here's an example of the SQLite database browser GUI, how it parses out the data. It will tell you exactly, the current path of it, what file was it, what time it would start downloaded, and how many bytes was it. One thing about these SQLite databases, it's also tell you the state of the download. So it's great for investigations if you're chasing something after that. The question is, did he really download it? Was the download successful, or was it corrupted? Or did he really download it, and did he click on it or not, the attachment? So this is great for investigations, great for incident response team. Of course, there's another example. As you can see, using the browser history view, you can, or browser download view here, you can see the file name. So if you have the investigation, you want to know exactly if that file is being downloaded or not, where it downloaded from, what web page it was from, start time and end time, download the bytes and stuff. So usually when you have the hash and you have the size, you exactly know exactly, yeah, this is what I'm looking for. So it's pretty quick and efficient. So what do I see in the future trends here? A lot of, we talked about the AIs and stuff, and shortage of, people in practitioners' role here. I see the need performing forensic analysis within the web browser is on a mobile device, because everywhere now you see is people using the mobile device, and everything is on the cloud network too as well. So there's going to be a lot of growing need in there. As I look toward the future, I see two trends likely to emerge as technology and business continue to grow with AIs and stuff as well. The data privacy effort will create a lot of challenge for forensic and investigations, stuff like this. Increasing in cybercrime, creating demand of talents such as the forensic practitioner in the field as well. And as AI is getting more and more, it's going to be harder for us to do any type of forensics itself. So in conclusion, while the web browser itself play very important to the internet access, they continue to be targeted by the threat actors, not just email, but everywhere you go, click on a website, you never know what you're going to get. So analyzing the web browser artifacts, it definitely helped the investigations understand the objective of the criminal activity in terms of their method or what they're trying to accomplish, especially inside threats. So examining the suspect system with the web browser analysis logs, to me, has remained the key effort, key artifacts for most of the investigations. With that, I'm going to turn back to the rock star for PowerShell.
Thank you, Tuan. And to be clear, the only thing I ever use the internet for is to search for pictures of you, buddy. So some PowerShell artifacts collection. This is really about commandlets and commands that you can use, string together for collecting artifacts, doing eDiscovery, that sort of thing. So we'll start talking about that. The inspiration for this really comes off of LawBass, the idea behind living off the land binaries and scripts, which is something offensive security professionals and threat actors alike like to do. And I'm thinking, well, we too, or is it two, can do that as well. We can play at that game. So the objectives are to leverage PowerShell to collect digital forensic artifacts from the standpoint of being investigated. This is really based on the RFC 3227, specifically section 2.1, which is the order of volatility. I've come here and talked about that last week. I've got a funny story about the RFC. And access times. Mostly what I've got are get dash commandlets in my examples here, because those are things that typically aren't going to alter the OS. We also want to avoid installing or importing third-party modules, things like that. So we want to try to work from as much base PowerShell as possible rather than using some of those things. Quick warning here, there are some areas where you might want to run PowerShell as administrator to do some of these tasks. I'm going to talk about those in the slide deck because when you have PowerShell running under elevated permissions, the question might be, well, why did you do that? Because you might be altering the system. There's a couple specific use cases that you can actually use to cite and reference as a reason why maybe you wanted to do that, and we'll touch on those here in just a little bit. PowerShell logging, understand. So who here by show of hands loves doing documentation? There's like a few, like there's always a couple in every crowd and everybody else is looking around going, not me. So here's one cool thing about PowerShell is we can automate that. It actually will track the start and stop time of commands. It captures the input and the output of those commands. And so to do that, we simply do a start-transcript-path. We specify our path and file name. And then if we append -no clobber at the end, that appends to the file so it doesn't accidentally overwrite it. So if we start that in our collection process, it's logging the start time, everything we type in, and everything that PowerShell spits back about the system. And so it does all that heavy lifting for us. And then when you're done, you do stop-transcript. That basically logs the out time to that particular file. So we've captured the beginning and the end time and all the steps that sort of happened in between. Now, one thing that's helpful to collect is the PowerShell version on the system. So PowerShell has a lot of different environment variables. Here's one of them, the string PS version table. And in newer versions of PowerShell, 5.1 and above, also gives you the PS edition. So that's just helpful information to collect so you know what version of PowerShell and potentially what edition you use to collect these eDiscovery artifacts. Quick pro tip here. So I tend to think of things really how they relate to Linux. So I think of like the -v for verbose, -vv for very verbose, and -vvv for very, very verbose. PowerShell has something similar. If you pipe to format -list, think of that as getting more verbose output. One of the things when you're collecting digital forensic artifacts that's sort of painful about PowerShell is it tends to truncate things down to specific text sizes. That's not what we want when we're collecting forensic artifacts. So if you do the pipe format -list star and append that to the end of everything that we talk about in this deck, that will give you a little more verbose output. But what I really recommend is the last one, the pipe format -list -property star. That will give you full details without truncating the data so that we don't lose file names, we don't lose paths, we don't lose some of those important details that might be super helpful as we're doing our documentation on our eDiscovery for those artifacts collections. Getting system time, very good idea. So frequent time stamping command activity during an investigation, before and after each step, really is ideal. And again, if we started the transcript earlier, we can just run this throughout and it'll keep a running tally of what we did and when. So get-date will give us the basic date. Get-time zone tells us the time zone that the endpoint is collecting these artifacts in, which is helpful, particularly when you're trying to correlate events across multiple systems that might be in different time zones or might be in GMT/UTC time on some systems versus others. So super helpful. It's also helpful to know how long the system's been running. In particular, if we're doing this shortly after our memory collection, get-update -since, and again, we would pipe the format -list -property star. Ideally to get like all of this stuff and make sure we're not missing details here. Again, what I would say is append that to everything that you would run here. So that tells us the uptime on the system, the running uptime, if you will. Get-computer info-property OS last boot up time essentially tells us how long the system had booted up. It's another way to get that information if you don't have PowerShell 6 and the previous command doesn't work for you. Get-computer info-property OS uptime tells us, again, the uptime of the operating system. So these are helpful things to know how long system's been running. And then, again, if we have to convert to GMT, UTC time, you can do the string time equals get-date and then do a string time dot to universal time, and open and close paren will essentially give us the UTC time. That really, again, just helps us correlate what happened when across different systems and also understand, okay, we collected the system artifacts at this time, but here's how it translates to UTC, which doesn't have things like daylight savings and all those other things that make it tricky. So hashing files is something we do a lot in, incident response as well as forensics. So, Linux, we can simply run like an MD5 sum or SHA-256 sum and then the file name and get that information. PowerShell, we can kind of do that just a little bit more. So get-file hash, we specify the file we're wanting to hash, and then -algorithm, and we have different hashing values that we can provide. So we can get the SHA-1, 256, SHA-512 if we want, MD5, those sort of things, and that will give us the hash value of a file. We don't need to rely on a third-party tool. We don't have to install something on the endpoint to get that information. It's baked into PowerShell. Volatile network artifacts, and again, the idea is we try to get the things that are most likely to disappear first, again, based off of RFC 3227, subsection 2.1, the order of volatility. One thing that's going to disappear quickly is ARP. So if we get or I'm sorry, get-net route will give us our ARP cache. We can use get-net neighbor just to see some of the network traffic details. There also, we can see what IP addresses an endpoint speaking to by doing get-net TCP connection will give us TCP data. Note that UDP is a connectionless protocol, so the next command isn't get-net UDP connection, it's get-net UDP endpoint, because of course UDP is a connectionless protocol, so it's called different things. And then get-DNS client cache is super important because that actually shows the DNS that an endpoint's been talking to. So if you're wondering what hosts, what subdomains, what domains, that's going to spit out that information for you. And again, we want to get it fairly early in the process before the cache essentially flushes out and clears out on its own. Processes and services, super helpful to know what was running on an endpoint at the time you started doing live acquisition. So get-process will give you that. And then get-service will show you what services are running. And again, if we're getting all the full details, as I talked about earlier, it will show us things like what services were set to start up automatically, what may have been disabled, what was set to manually run or on a delayed start. Those become really important things, particularly if we think malware may have installed itself as a service. You know, for a number of reasons. One, it's a little trickier to get rid of, but also as a persistence and potentially, you know, an evasion tactic. There's a lot of reasons to install bad stuff as a service. So that helps us collect that information. The less volatile network artifacts, again, not that they're not important, but getting the DNS information with get-DNS client is really helpful. Get-DNS client server address tells you the DNS servers that the endpoint's communicating with, particularly if you suspect something has been poisoned to get its DNS from an alternate source. This is a definitive answer telling you the system was using this particular DNS server to do its resolutions against. Get-net IP address will give you the basic IP address information. You get a lot more details on that network connection using the get-net IP configuration commandlet. And then finally, get-net adapter shows you which adapter. Was it the wireless that was connected that was doing all the traffic, or was it plugged into the LAN? This will give you the adapter information, and you can see which, you know, sort of takes precedence on the OS, particularly if you're getting out those full details as we've talked about. Users and groups. Unfortunately, PowerShell just doesn't have a get-logged on users commandlet or something similar. It'd be great if it did. So you can kind of use a get WMI object win32 underscore logged on users, select antecedent unique to try to filter out duplicate information. It kind of works. I'm not a huge fan of it. Technically, it runs in PowerShell. Technically, it's not a PowerShell commandlet, but I still think query user is a much better command to run, and you can run in PowerShell to get an idea of who was logged on locally to that host at the time you were doing that acquisition. Get-local group will show you what local groups are on the endpoint itself, particularly in a Microsoft Windows system. You know, sometimes groups could be created, altered, those sort of things, and you want to know, you know, maybe what users are part of a group, those sort of things. You know, did something get added to the local systems administrator or the remote desktop users group? This will help answer those kinds of questions for you. And then get-local user select star will kind of give you an idea, was there a local account that was added to an endpoint? Now bear in mind, just because there's a local account on the endpoint doesn't mean that that account has necessarily logged into it, but it does mean it could have. And then we'll talk a little bit later. It's not a perfect solution, but get-child item, the C:\users folder will show you what user profiles are on the system. That's not to say those things couldn't potentially be deleted, but it is a really good indicator, because usually on an endpoint, you're not going to have a user profile folder built out if that account has not actually logged on to a system, unless it was tampered or altered with. But also, you know, if you compare that against your list of local users and there's not that folder, there's a good chance it's not been logged on to, or, you know, maybe the local user account was removed, but there's that profile on that system, but it didn't come from the domain, might be evidence of some tampering. So these are really important artifacts to collect from the investigation standpoint. Policy. So PowerShell can run with different execution policies. So these are particular for scripts. Now this can obviously be bypassed from the command line by using a bypass execution policy, but this will tell you at least on the system specifically if, for example, something would just run unrestricted code. It could run just about any PowerShell script. It might require that it be signed locally within your environment, or it might actually require a trusted certification authority having a key on a script before it'll actually run it. This actually tells you what the execution policy of PowerShell is set to at that particular point in time. Now the get execution policy list gives you a little bit more detail. Specifically, it will tell you for each scope. So for example, you could have different execution policies on the local workstation if it's on a public network versus a private network, if it's on the domain, off the domain, those sort of things. That gives you those full details. Again, it's not perfect because that can be bypassed, but it does tell you maybe natively what may have run without any shenanigans or altering of the system. It's just good to understand what the permission levels are at when you're looking at an endpoint. Clipboard, the auto runs, and tasks is also pretty important. Now, one real quick note here is this really tells you that account logged in. So in a perfect world, you're still logged in as the user that you're, from which you're investigating the system. If you've logged them off and you log on as yourself, you're just getting your own clipboard. But if you have that live acquisition from the other user's account, you can actually copy out the contents of what was in their clipboard by using the get-clipboard commandlet, which is super helpful. Get-sim instance win32 startup command will tell you what's set to automatically run on the system. And so that's really helpful to know. That's one of many persistence techniques, as is scheduled tasks. And so conveniently, there's get-scheduled task, which will tell you this system has these scheduled tasks that are set to run. Those may be situation normal, or it may be running this really weird PowerShell script on the system that looks out of place or is obviously something that probably shouldn't be there. That'll spit out those details for you and tell you what's set to run automatically. So these are, when we're investigating the endpoint, very important details to understand, uncover, look at, and document. And then host details, we can use the following to collect additional details such as installed device drivers. So a lot of rootkits now, for example, very hard to get a rootkit on a system, but one of the easier ways to do it now is with infected drivers or malicious drivers or vulnerable drivers. So we can get those details, programs, hotfixes, disk drive, and other system details. So the get-windows-driver-online-all. This is one of our use cases where you can justify potentially running PowerShell as administrator because you need those level of permissions to get details on the drivers on the endpoint, which we just talked about, why that's kind of important potentially. Get-package shows you what's been installed on the system. So that one's pretty self-explanatory. You can see what was installed on the endpoint. Doesn't mean it might not be a standalone executable or fileless malware, that sort of thing, but it gives us a good idea for things that are actually on disk. Get-hotfix will tell us what hotfixes from Microsoft have been applied to the OS. And then get-ps-drive will tell us the drive information on the system. So, is there an ISO mounted? Is there a hidden partition? Are there multiple disks? What drive letters are they mapped to? Those sort of things. It gives us a lot of good detail there. And then get-computer info spits out a ton of information. So you're getting the uptime, you're getting the system name, was it domain joined, which domain is it logged into. It gives you just a ton of host details that, again, if we're logging and we're collecting that with our start transcript, it really tells us a lot about the system as it was running when we did this collection. In a perfect world, we would be able to just tell what open files are running on the system. So there's some caveats here. So get-smb open file will tell you what was running or what was open on the system from remote from that system. It doesn't tell you maybe it was locally run on that system, which would be ideal. And again, that's another example. It requires administrator level privileges for PowerShell. And again, it only shows us things that are open from a remote host. And we have the same thing with the open files-query. When you run that, it'll actually tell you that the system global flag maintain objects list needs to be enabled to see local open files. So that would give us the details. Now you might think, aha, I can just turn that on and rerun the command and it'll tell me what local files are open, right? Unfortunately, no. Because if you run open files/local on, it will tell you, and again, you have to run as administrator to do it, but it doesn't take effect until the system is rebooted. Now, you could preemptively enable that in the environment, and the system will track the open or the local files that are open on the endpoint, and that's helpful. It does, however, come at a performance hit. How impactful would that be to your environment? I can't really answer. There's too many variables at play. Really, you have to kind of benchmark a before and after. It might be something where you have it turned on in the majority of your environment, but you have a database server or developers and they can't be hampered because they need every last ounce of performance they can squeeze out of their system. Maybe you can have some carve out exceptions through group policy or something like that. So it's just something you have to experiment with, benchmark the befores and after, figure out where you can turn it on. If you can turn it on, it's super helpful to have it. Just know, by default, Microsoft doesn't turn it on for you. That's something you need to do to see those open files, which would be so great if it was just automatically there, or we could flip it on a switch, get the open files and turn it back off. Unfortunately, just doesn't quite work that way. This just barely scratches the surface on PowerShell stuff. There's a ton of great stuff out there. Again, grab a copy of the slide deck. Microsoft has a whole learning section on PowerShell, cmdlets. They've also got the PowerShell core that again tells you a lot of what's built in that don't require you installing external modules and those sort of things. And then with that, open it up for questions either for Tuan or for myself. And again, go out to slides.dfirmat.com. You can grab it'll redirect you to my GitHub repo. You can grab a copy of the slide deck and hit us up. So any questions?